Good afternoon, everyone. I'm Ivan Carlo, and it is my pleasure to introduce you to this semester's course in Environmental Biotechnology. The BioTeach project aims to bridge the gap between universities and industry and facilitate the transition from university to industry by bringing together biotechnology students and industry representatives. By the end of this course, you should be able to understand the production and separation of biodiesel. I am very excited to dive into this subject matter with you and hope you find it as fascinating as I do. Let's now look at an incredibly promising sustainable energy pathway, the biodiesel production. With the urgent need to reduce greenhouse gas emissions and combat climate change, biodiesel offers itself as an alternative to traditional fossil diesel. Biodiesel is a renewable fuel produced from organic materials, usually vegetable oils or animal fats. The production process involves a fascinating synthesis known as transesterification. In this project, these oils or fats react with alcohol in the presence of a catalyst to produce biodiesel and glycerol. It is a relatively simple process with profound implications for reducing our dependence on non-renewable resources. However, despite its potential, biodiesel production is not without its problems. A major problem lies in the separation of the biodiesel from the reaction mixture. The separation process can be energy and cost intensive and often requires complex equipment and multiple steps. Improving this aspect of the biodiesel production is crucial to make the process more efficient and economically viable. In addition, there are gaps in this technology used for biodiesel production. While significant progress has been made in recent years, there is still much room for innovation. Research and development efforts need to focus on developing more efficient catalysts, optimizing reaction conditions, and exploring alternative feedstocks to make biodiesel production more sustainable and scalable. In addition, the environmental impact of biodiesel production must be carefully considered. While biodiesel itself is a clean fuel compared to conventional diesel, the production process can still have an impact on the environment if not managed properly. Sustainable practices and careful resource management are essential to ensure that biodiesel remains a truly environmentally friendly alternative. Certainly, the separation of biodiesel is a crucial step in the production process, but it presents some challenges that need to be addressed for efficient and cost-effective biodiesel production. Here are some key issues related to biodiesel separation. One of the biggest challenges in biodiesel separation is the formation of emulsions during the reaction process. Emulsions are formed when the biodiesel and glycerol phases are finally dispersed into each other, making separation difficult. Emulsions can be stabilized by various factors such as surfactants, stirring, and high temperatures, which further complicates the separation process. The next problem is the high energy consumption. Conventional separation methods such as gravity separation, centrifugation, and filtration can be energy and time consuming. These methods often require large amounts of energy for heating, cooling, and mechanical agitation, leading to increased production costs and environmental impact. Incomplete separation is also a problem. The complete separation of biodiesel from the glycerol phase is a challenge, especially when using conventional separation methods. Residual glycerol in biodiesel can affect its quality and performance, leading to problems such as reduced fuel efficiency and increased emissions. In some biodiesel production processes, catalysts are used to facilitate the transesterification reaction. However, the removal of catalyst residues from the biodiesel can be problematic and require additional purification steps, increasing production costs and complexity. Scalability is also an issue. While certain separation methods work well on a laboratory scale, Scaling up to a commercial production level can pose additional challenges. Factors such as reactor size, residence time, and mass transfer limitations must be carefully considered to ensure efficient separation and production. Overcoming these challenges requires innovative approaches and technologies. Research is working on the development of novel separation processes such as membrane separation, adsorption, and reactive distillation, which offers the potential for higher efficiency, lower energy consumption, and better product quality. In addition, process optimization, control strategies, and the integration of multiple separation steps can help overcome the challenges associated with biodiesel separation and drive sustainable biofuel production. To summarize, the production of biodiesel as a renewable energy source is promising and has the potential to mitigate climate change and reduce our dependence on fossil fuels. However, to fully realize this potential, we need to address challenges such as separation efficiency, technological gaps, and environmental concerns. Through continued research, innovation, and collaboration, we can realize the full benefits of biodiesel and pave the way to a more sustainable future. To get the most of this course, stay engaged, attend lectures and labs, complete assignments on time, and get help when needed.